Good morning, my name is Emily Robison, and I'm going to be talking again about polypropylene fumarate. So my paper was on called nanocomposite scaffold fabrication by incorporating gold nanoparticles into biodegradable polymer matrix. It's talked about the synthesis, characterization, and photothermal effect. So this was looking at adding gold nanoparticles, and so kind of throughout the presentation you'll see AUNPS. That's just shorthand for gold nanoparticles. It's kind of used throughout the paper. And so they're looking at the addition of the polymers to the matrix and how this can be used in biomedical applications for drug release, as well as they're looking at the photothermal effects specifically because they can get localized thermal effects by using irradiation from a laser. And what they're doing is they're actually applying this at like the site of like a cancerous tumor and being able to treat the tumors that way. So this is kind of seems like an up-and-coming technology. It was published in 2015, so pretty recent paper, and they kind of, as I'll mention later, they've got some studies that they're still continuing to do and still working on. So the primary materials used were PPF and DEF. The inclusion of the DEF in that mixture is to be able to achieve the appropriate viscosity to be able to manufacture the material properly and quickly. And then the gold nanoparticles are added. So at one point in the presentation we'll talk about, they looked at a variety of this mixture, looking at varying the volumes of the gold nanoparticles that was used. So the processes examined was by changing the volume of the gold nanoparticles, and they looked at some thermal imaging, spectroscopy, and looked at nanoindentation when they're looking at different material properties of the scaffolds they were making.
Transmission electron microscopy.
Yes.
So you're just imaging things at that nanoscale.
Mm-hmm. Yeah, and they were also doing some other thermal testing as well, kind of throughout here. So, one of the things they did is they applied this PVP coating. This is supposed to help reduce or increase the colloidal stability by and decreasing the chains of aggregation. So, in order to achieve a homogeneous solution, the colloidal stability is kind of the likelihood of like all of the little nanoparticles kind of clumping together, and they just want to make sure that then like kind of once it clumps together, if it stays together, if it's going to break apart. So that's kind of, they want to make sure that it's going to be evenly dispersed and stay evenly dispersed in the resin at the time. So this is really important to make sure that they've got an even distribution throughout the part. Using the PVP coating, they were able to maintain the same absorption nearly as before, and they were able to achieve the increased stability that they were looking for. Another thing, so since we're looking at the wavelength is going to be important just because of the way that they're heating or using the lasers to irradiate the material, and so they added the BAPO, which is a photoinitiator, and they were able to achieve a high absorption rate at in the UV spectrum, which is what they were looking for, compared to without the photoinitiator incorporated. So this is a picture of the nanoparticles in the DEF matrix, and kind of showed how the dispersion of it and how it was fairly homogeneous. This is what they were looking for. They were satisfied with the results of how it was. One of the comments that they did make is that the images were hard to get because it was because of the wavelength and how it was acting, was that it started to cure as soon as they took the images. So that was kind of difficult to get a good image, but overall they were very happy with how homogeneous it was, and said that this would definitely be good for the applications that they were using. So they also looked at the mechanical and thermal properties. So graph A shows kind of thermal properties, and B and C are just zoomed in on the different sections of graph A. And so you can see that as we varied the concentrations of the gold nanoparticles, each of the different colors is a different variation. All the different concentrations are listed below. you can see that there's very, very little change in the thermal effects, which is what they were looking for. But they did say that it was an increased stability in the thermal properties. But one of the big important things for them was looking at chart D, is looking at mechanical properties, and said that they started to degrade significantly after we reached the 0.16 concentration of nanoparticles. And they said that this was that the peak was there because that was where the increased cross-linking occurred, and had it started to degrade after that. So they recommended that's the optimum mixture that they should use. And so, in summary, they determined it was feasible to use the gold nanoparticles to incorporate into a biopolymer resin. So they were able to verify that the photosensitive material allowed to control scaffold temperature. That was kind of all the tests that they did with regards to the wavelength and range and where it was at. And the mechanical properties were improved, and were able to determine the best ratio of volume percentage, I guess, of the gold nanoparticles. And so one of the critiques was that this required a lot of background knowledge that I definitely did not have. It was very difficult to get through. While it was a short paper, it was very difficult to get through the first time and the third time through the paper. So it was really hard to understand, but I liked how they also, at the end, they discussed a lot of the applications, kind of like why they're using it in for like treating tumors and how they're doing that. And they also mentioned that they're actually taking the results from this study and applying it to a study where they're placing these in lab rats and doing testing on that, and kind of mentioned a little bit of how they've been having some success with that. They've overall very positive results, haven't had any negative side effects at this point, and so they said that they'll be releasing another paper on that subject, but I thought it was neat that they included that they were talking about that and how successful it's been so far.